The first one is different direct integration method, separation of variable method or variable separable method, homogeneous method, non-homogeneous method, and exact equation method. So let's take the first one, direct integration method. Okay, for the direct integration method, let's say given a function of this form, a differentiation of this form, dy over dx equal to f of x. For us to be able to solve this differential equation, we have to separate the dy and the dx. For us to be able to solve the direct integration method of this form dy over dx equal to f of x, we have to move the dx to this other part. Therefore, the equation will be dy f of x dx. Then when you have gotten to this form, you can now integrate them directly. So we integrate dy over f of x dx. Integrating this, you get integral of dy is y. Then let's say the integral of f of x, you get g of x plus constant of integration. Now let's take an example. Okay, welcome back. Let's look at direct integration method of solving ordinary differential equations. Let's see this example. The x squared minus 3x plus 2 dy over dx equal to 2x minus 3. Let's see how we can solve this using direct integration method. Let's write out our equation. Okay, first of all, let's look at how we can make this dy and dx on a separate side. Dy should be on a separate side. Dy should be at the right hand side, while your dx should be at the right hand side. So let's divide through by this equation. Divide both sides. Okay, we are going to divide both sides of this equation by x squared minus 3x plus 2. Okay, dividing the both sides of the equation by this. This one is going to cancel out this one, then we'll be left with dy over dx, which is equal to 2x minus 3 over x squared minus 3x plus 2. Then once you have gotten this, we'll look for a way in which we can make all variable of x to be at one side and y solving a differential equation, we should try to make our value of y or the y at the right hand side, while the x or x at the left hand side. Okay, for this, for us to separate the y over the x, we can multiply both sides of the equation. Multiply both sides of the equation by the x. Multiplying both sides of the equation by the x, we'll have the x, the y, all over the x, which is equal to 2x minus 3 over x squared minus 3x plus 2 times our x. Therefore, this x here, the x here can cancel out the x. Here, there will be left with dy equal to 2x minus 3 all over x squared minus 3x plus 2. Therefore, then our dx, once you have gotten to this part, we can now use the direct integration method to integrate this. Okay, let's integrate through this equation. Integrating through half integral dy equals to integral 2x minus 3 all over x squared minus 3x plus 2 dx. So, for the left hand side, integral of dy is y. Then for us to be able to integrate the right hand side, let's say let u be equal to the numerator. Let u be equal to the numerator. That is x squared minus 3x plus 2. Then let's differentiate u with respect to x. That is du over dx. Differentiating du with respect to x, we will have differentiating x squared, we get 2x minus differentiating 3x, we left with 3. Then this is our constant, differentiating constant is 0, so we are not going to be writing it. Therefore, let's look at how we can make the x a subject of formula. Making the x a subject of formula from this, we get du equal to 2x minus 3 dx. And we are looking for how we can make the x a subject of formula. Therefore, you divide both sides by 2x minus 3. It becomes du all over 2x minus 3 equal to dx. Therefore, this becomes our dx. We can now substitute this value. You can now substitute this and this into the integral. So we are left with y equal to integral 2x minus 3 all over. In place of this x squared minus 3x plus 2, we are going to put in u. Then in place of the x, we are going to put in du over 2x minus 3. Then looking at this, we can see that 2x minus 3 is here and 2x minus 3 is also here. This can cancel out this. Then we'll be left with